Hello friends, given this function f of x equals a of x over b of x, we want to find the derivative and we are going to use the quotient rule. The question is, when do I know that I have to use the quotient rule to find derivatives? When you have a ratio of two functions, what do I mean? If you have a function divided by another function, so when you have function like that, you might be able to use quotient rule. And the reason why I said you might is that sometimes, even if you have a ratio of two functions, you don't necessarily need to use quotient rule. You can just simplify the function and find your derivative. So let's quickly talk about quotient rule here, right? So what is quotient rule? To use quotient rule to find the derivative of this function, using quotient rule is going to be the derivative f prime of x is going to be, you take the derivative of the numerator, which is a of x, right? Take the derivative of that. The derivative of that is going to be a prime of x. Then you keep the denominator just the way it is. The denominator is what? The denominator is b of x. So you keep the denominator just the way it is, minus, you take the derivative of the denominator, which is b of x. Derivative is b prime of x, and you keep the numerator, which is a of x. You keep the numerator just the way it is. So it's going to be times a of x. Then everything divided by the denominator square. So the denominator is b of x. So you have b of x all square. So that's the quotient rule. Okay, let's quickly take an example. Look at this example. Given f of x is equal to x squared over sine x, find f prime of x, find the first derivative. In this problem, for this problem, we cannot simplify. There's nothing we can do, right? We just need to find the first derivative. So what I'm going to do is I'm just going to copy this quotient rule. I'm just going to copy it and just put it side by side. Just put it somewhere here so that we can look at it and apply the quotient rule. So if you look at this problem, what's my a of x? My a of x is going to be, my a of x is x squared, and then my b of x, if you are comparing this problem with, with what we have here, right? With what we have here. So my a of x is just going to be x squared, and then my b of x is sine x. So the derivative of this function, I'm going to write it down here, f prime of x, is just going to be the derivative of a of x, right? So my a of x is x squared. The derivative of x squared is just going to be 2x, right? Then times, I keep b of x just the way it is, right? Because that's the next step if you're following this. So this is it, b of x. So I keep b of x just the way it is. So I have b of x is what? Sine x. Then I have minus, then the derivative of b of x, right? Because the next step now is to, this is the next step, right? Derivative of, that's b prime of x. So the derivative of b of x is sine x. The derivative is what? Cos x. Then I keep a of x just the way it is, right? Then I'll keep a of x just the way it is. Keep a of x just the way it is. So this is my a of x. So I'm going to keep a of x just the way it is. So which is x squared over b of x squared. And b of x is sine x. So I have sine x all squared. Yeah, so that's using the quotient rule. That's the derivative of that function. That's the derivative. Okay, so now let's take another example. Now, this example, we want to find the derivative of this function. F of x is equal to x to the power of 4 divided by x squared. So, how can we do this? We can use the quotient rule, but the question is, do we necessarily need to use the quotient rule? Maybe we don't, because we can simplify that function, right? So I have the function f of x equals x to the power of 4 divided by x squared, I can use the rule of exponent, right? That if I have the same base and I'm dividing two function, right? I can just, so if I have x to the power of, let me write it by the side, using the rule of exponent, x to the power of m divided by x to the power of n. This is just this x to the power of m minus n, right? So using that rule, I can write this as x to the power of 4 minus 2. This is x squared, right? So that means actually my f of x is equal to what? X squared. So the derivative of x squared, you can find that using the power rule, right? So f prime of x is just going to be 2x using the power rule. So that's the derivative. Okay, let's just assume that this, what we just did now, this method did not come to your mind. And what came to your mind was quotient rule. Oh, I have a ratio of two functions. Quotient rule. We can apply quotient rule, and we are going to use quotient rule. So let me just write using quotient rule. Right. So for this one, this is our solution, right? F prime is 2x. So using quotient rule, so the numerator, right? The numerator is, this is our a of x, right? That's the numerator. And the denominator is what? Is the denominator is, this is our b of x, right? Okay. So using the quotient rule, so I'm just going to copy copy this quotient rule, just copy it, and then we can just follow it. So using the quotient rule, just going to copy it and put it by the side. So you take the derivative of the numerator. You take the derivative of the numerator first, right? So let me write the problem. F of x equals x to the power of 4 divided by x squared, right? So you take derivative of the numerator, which is your a of x, and you keep the denominator the way it is. So my f prime of x, the derivative of the numerator, which is x to the power of 4, is going to be 4x cubed. Then, right? Then I'm at this stage now where I keep the denominator. This is the denominator, just the way it is. Keep the denominator just the way it is. So that's just going to be x squared. Then minus, then I'm going to take the derivative of the denominator. So the derivative of the denominator, this is the denominator. I'm going to take the derivative of the denominator. So that's just going to be 2x, right? Times, I keep the numerator just the way it is. So what's my numerator? My numerator is going to be x to the power of 4. So I have x to the power of 4 divided by the denominator square, which is x square, right? The denominator is x squared, then you square that, right? Now let's simplify this. Let's see if we are going to get 2x, which is this answer that we got above. So if we simplify this, so we have, using the rule of exponent, so we have 4. If you combine this x to the power of 3 and x squared using the rule of exponent, right, you add the power, right? So you have x to the power of 3 plus 2, that's 5, minus. Then you can combine this x and x to the power of 4 together, right? Using the rule of exponent, you are going to get 2x to the power of 5. Then the denominator is just going to be x to the power of 4, right? And if you simplify the numerator, you get 2x to the power of 5 divided by x to the power of 4. And using the rule of exponents, right, this one here, right, x to the power of m divided by x to the power of n is equal to x to the power of m minus n. I can apply that rule on x to the power of 5 divided by x to the power of 4. So this is just going to be 2x to the power of 5 minus 4, right? And this is just going to be 2x to the power of 1, which is equal to 2x. So actually my derivative f prime of x is just going to be 2x, which is the same thing, as what I got here. They're the same. So if you use the quotient rule, you're still going to get the same answer, but it's just longer, right? But if you're able to quickly realize that, oh, x to the power of 4 divided by x squared, I can use the rule of exponent to simplify it, you can make your work, shorter, right? So that's it. So let's take another example. Okay, we want to find the derivative of this function. How can we do this? Do we necessarily have to use the quotient rule because we're having a ratio of two functions? Maybe not, because looking at the numerator, I can factor this numerator, right? I can factor the numerator. So I can rewrite my function. If you factor the numerator, so I can rewrite my function to be x plus 1 square over x plus 1. Because if you factor the numerator, x squared plus 2x plus 1 is just going to be x plus 1 squared, right? And this is actually x plus 1, right? And this over x plus 1. So this can cancel this. Then I'm going to be left with x plus 1, right? So my f of x is equal to x plus 1. So if you take the derivative of your x plus 1, if you take derivative of x, you get what? If you take derivative of x, you get 1, plus if you take derivative of 1 is a constant. If you take derivative of that, you get 0. So your derivative is just 1. So yeah, so that's it. So you see that we did not apply the quotient rule here because we can just easily simplify the function and and just find our derivative using the power rule. I hope this helps. Thank you.